So what is the difference between supervised and unsupervised learning? Yes, so in the supervised learning we know the class of each tuple, and we want to create a model, and this model will predict the class of unknown data based on unknown data or on historical data. In the unsupervised learning, no class labels, so the class labels of training data is unknown, and we want to create clusters or groups. We want just to group data together in one group, and based on what? Based on similarity. So if the data or if the tuples are similar, we will group the tuples together in one group. Okay, after that there are two steps when we make classification. Two steps. What are the steps? Two steps. What are the steps in classification? Two steps. So in classification there are two steps: the model construction and the model usage. In the model construction we will use the training set to create the model, and in the model usage we will estimate the accuracy of the model. After that, if the accuracy is acceptable, we will use this model to classify new data. It is clear? Do you hear me? Okay. So this is the first step, the model construction, and the second step is the use of the model in prediction. So this model will predict the class of other data. So what is the relation between testing data and training data? Here we have training data, and here we have testing data. What is the relation between this data? Training and testing. Yes, very good. So we will extract the model not from testing but from training. So training data is used to create the model, and testing data is used to evaluate the model. So the tuples that the tuples of the training data must be different. Okay, so training data, if we make intersection between training data and testing data, we will obtain an empty يعني ما بنجد شيء مشترك بين الاثنين. Empty set. Very good. Thank you. Good. Also we discussed decision tree induction. So what is the decision tree induction? What represents decision tree induction? So decision tree induction is a supervised learning technique. A supervised learning technique, or also a classification technique or classification method. Okay? So in decision tree induction, the model is represented as what? It is represented by the model in the decision tree is represented by what? Not label. So the model or the knowledge in the decision tree is represented as what? Our model. So in the decision tree, our model is represented as a tree. Yes, here. This is our model. All this represents our model. So we can convert this model to rules if then else. How we can convert this model to rules? From what? We begin from what? So to convert this model to rules, we begin from the root. After that, until left. For example, the first one is if age is less than 30 and student equal no, then by computer equal no. So why we begin with age in this decision tree? Why we don't use income or student or credit rating as first test? Why we use age as first test here? And why we use student here? Based on what? We will choose or we will select age or income or student or credit. The best, yes, it is the best. The best what? Yes, very good. Based on entropy. So we have to calculate the gain. The gain of entropy, the gain of age, the gain of income, the gain of student, and the gain of credit rating. After that, we will select the attribute with the maximum gain. Is clear? Okay. After that, we discussed also the overfitting. So what's the meaning of overfitting? What's the meaning of a decision tree overfit the training data? So overfit the training data, that means the model gives us a good accuracy for training samples and poor accuracy for ancient samples. This is the mean of overfitting. And what are the approaches to avoid overfitting? Pre-pruning, halt reconstruction early, do not split a node if this would result in the goodness measure falling below a threshold. And post-pruning, that means after the construction of this tree, we will remove branches. We discussed also in face-to-face class scalability framework, and we said that for the meaning, what's the meaning of scalability? Scalability, so scalability, that means classifying data set with millions of examples and hundreds of attributes with a reasonable speed. This is the meaning of scalability. After that, scalability framework, we can use the rainforest with AVC set, and we can use bootstrapped optimistic algorithm for tree construction. Okay, let's move now to base classification methods. So base classification methods is another method or technique to classify data. So base classification method can be considered as supervised or unsupervised learning. Yes, supervised. So base classification method is a supervised learning. So Bayesian classification, why? So Bayesian classification is a statistical classifier, performance probabilistic prediction, that means predicts class membership probabilities, and the foundation of this classifier is Bayes' theorem. Performance, so a sample Bayesian classifier, naive Bayesian classifier, has comparable performance with decision tree and selected neural network classifiers. So keep in mind that a Bayesian classification is incremental. Each training example can incrementally increase or decrease the probability that a hypothesis is correct. Prior knowledge can be combined with observed data. And standard, even when Bayesian methods are computationally intractable, they can provide a standard of optimal decision making against which other methods can be measured. So here we will use probability to predict the class of a tuple. So what is the difference between Bayesian classification and decision tree? In the decision tree, we will construct a model. In our case, the model is a graph or a decision or a tree. And after that, we will use this tree to classify a new tuple. In Bayesian classification, here, we will use probability. So the probability, the total probability theorem, sorry, probability of B equal the sum of I equal 1 to M of the probability B AI multiplied by probability of AI. So I will move directly to an example to explain how we can classify data based on Bayes' theorem. So this is our example. We have two classes here. How many classes we have? Are you here? Two, very good. Yes or no. Okay, and by computer equal yes, by computer equal no. We want to classify this tuple X. So for X we have age less than 30, income equal medium, student equal yes, credit rating equal fair. It is clear? So here we want to do what? We want to do what in our example? To classify what? We want to classify X. Yes. Yes, we want to classify X by computer or no. This is our task. And we will use the naive Bayes classifier. So naive Bayes classifier use probabilities to predict the class of X. Okay? So to classify X, we have to calculate the probability of by computer equal yes, that means the class number 1, and the probability of class of by computer equal no. Why the probability of by computer equal yes equal 9 divided by 14? Because here in our example we have 9 yes. 9 yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is clear? So 9 yes divided by 14. Yes. And here the probability of by computer equal no equal 5 divided by 14. The first step is clear for you. After that, we have to calculate probability of age less than 13. So here we will begin with age less than 13. So we have to calculate probability of age less than 13 if by computer equal yes, and probability of age less than 13 if by computer equal no. So that means in by computer equal yes, how many we have age less than 13? How many times? So here in yes, we have this one less than 13 and this one. So the probability is 2 divided by 9. Why 9 and not 14 here? Because we have 9 yes. Yes. Okay. After that, we will calculate also the probability of income equal medium. So here we will calculate probability of income equal medium if by computer equal yes, and probability of income equal medium if by computer equal no. It is clear? Okay. After that, we will calculate the probability of X with age. So also we will calculate probability of student equal yes and probability of credit rating equal fair. So here and with the same manner, student equal yes, we will calculate the two probabilities, this one and this one, and after that the last one is credit rating fair. You will calculate the probability, this one and this one. After that, we want to calculate the probability of X if by computer equal yes. So probability of X if by computer equal yes, in our example, we have just to multiply what? To multiply this value and this one and this one and this one. It is clear? So probability of X if by computer equal, yes, equal probability of age less than 30 if by computer equal, yes, multiplied by probability of income equal medium if by computer equal, yes, multiplied by probability of student equal, yes, if by computer equal, yes, multiplied by probability of credit rating equal fair if by computer equal, yes. We will obtain this value. This is the result. Okay? In the same way, we will calculate the probability of x computer equal now. So we will multiply 0.6 multiplied by 0.4, 0.2, 0.4, and the result will be, this is the result. After that, we have to multiply probability of x if by computer equal, yes, multiplied by probability if by computer equal, yes. This is the final result. We have to multiply by the probability of by computer equal, yes, here, and probability of by computer equal now here. So therefore, x belongs to by computer equal, yes. Why? Why x belongs to class by computer equal, yes, here. So the prediction in our example is by computer equal, yes. Why? Because here the final result, the probability is higher than by computer equal now, yes. It is clear how we can predict the class of a tuple using naive Bayes classifier. Any questions? Okay, so just to understand, here we have to multiply probability of x, the value 0.028. I just clear all the page. So we have to multiply this value by computer equal, yes, multiplied by this value. We will obtain this value. Okay. So there are many advantages of naive Bayes classifier. It is easy to implement and it provides good results in most of the cases. But the disadvantages is the assumption, so class conditional independence, therefore loss of accuracy, and practically dependencies exist among variables. For example, if our variables are hospitals, patients, profiles, etc., there is a dependency between all the variables. We cannot assume that probability of x1, x2, x3 equal the product of the probability of x1 and multiplied by x2 multiplied by x3. Let's move now to rule-based classification. So here the classification is based on some rules. Just a moment, please. Can you see the slides? Okay. So rule-based classification. Using if-then rules for classification. Represent the knowledge in the form of if-then rules. So for example, if age equal youth and student equal yes, then by computer equal yes. And here there are some assessment of a rule, the coverage and accuracy. Number covers equal the number of tuples covered by this rule, and incorrect is the number of tuples correctly classified by this rule. So the coverage of a rule equal the number of uncovers divided by the number of tuples in the training data set, and the accuracy of a rule equal the number of correct divided by the number of covers. Any questions about coverage and accuracy of a rule? It is clear? Okay, if more than one rule are structured, need conflict resolution. So size ordering, assign the highest priority to the triggering rule that has the towest requirement. Class-based ordering, for example, decreasing order of prevalence or misclassification cost per class, etc. So rules are easier to understand than large trees. One rule is created for each path from the root to a leaf. Each attribute value pair along a path forms a conjunction, so the leaf holds the class prediction. Rules are mutually exclusive and exhaustive. Example, rule extraction from our by computer decision tree. Here, the first rule if age equal young and student equal no, so here we assume that this is young. Sorry. If age equal young and student equal no, then by computer equal no. So the first, this is the first rule. It is clear? So how we can extract rule from a training data set? There are many manners to extract rules from a data set. We can talk about sequential covering algorithms, extract rules directly from training data set, and we can quote many algorithms. For example, FOIL, AQ, CN2, RIPER, etc. So rules are learned sequentially. Each for a given class CI will cover many tuples of CI, but none or few of the tuples of other classes. So what are the steps of these algorithms to extract rules? So rules are learned one at a time. Each time a rule is learned, the tuples covered by the rules are removed. After that, we will repeat the process of the remaining tuples until termination condition, when no more training examples or when the quality of a rule returned is below a user-specified threshold. This is the condition to stop the process. Any questions about rule and action? Okay, I will move now to model evaluation and selection. Evaluation metrics. So we said that in the construction or in the classification there are two steps. The construction of the model, after that the evaluation of this model. So the construction of the model, we will use the training data set, and in the evaluation of the model, we will use the test data set. So evaluation metrics, the question is how we can we measure accuracy? There are other metrics to consider. So we can use validation test set of class labeled tuples instead of training set when assessing accuracy. And there are many methods for estimating classification accuracy: holdout method, random subsampling, cross-validation, bootstrap, etc. And also we can make comparison between classifiers using confidence intervals, cost-benefit analysis, and ROC curves. Let's begin with the confusion matrix, classifier evaluation matrix. So this is a confusion matrix. Into a confusion matrix, there are in the columns we find predicted classes, and in the rows we will find actual classes. So this value will represent the true positive value, and this one the false negative value. Example of confusion matrix. Here by computer equal yes, 6954, 46, etc. So how we can interpret this confusion matrix? In by computer equal yes, we have 7,000 tuples. It is clear? From this 7,000, there are 6,954 by computer equal yes. That means true positive, correct. But 46 are assumed that by computer equal no. This is an error. It is clear? So we can, for example, in our example here, this is the test phase, and here we have our confusion matrix. So by computer equal yes, by computer equal no, by computer equal yes, by computer equal no. So here in our example we have 2 yes and 2 no. So in the 2 yes, 2 are correct. We have 2 yes and yes. Here in the predicted model, we have no, yes, yes, yes. So here 2 yes are corrected, 0 no, and here there is an error, 1 no, 1 yes, and 1 no. This is the matrix, the confusion matrix for this model. Classify accuracy or recognition rate is the percentage of test set tuples that are correctly classified. So in our confusion matrix, to calculate the accuracy equal TP, this one, plus TN, this value, divided by all. And the error rate equal 1 minus accuracy R. So and the error rate we will use Fn plus Fp divided by R. So class imbalance problem, one class may be rare, for example fraud. So significant majority of the negative class and minority of the positive class. The sensitivity through positive recognition rate equal TP divided by P. And specificity through negative recognition rate equal TN divided by N. Also, there are other measures that can be performed when we want to evaluate a classifier, especially the precision, the recall, the F measure, etc. So precision or exactness is what the percentage of tuples that the classifier labeled as positive are actually positive. This is the precision. So precision equal TP divided by TP plus FP. Recall is the completeness. So what is the percentage of positive tuples did the classifier label as positive? So the recall equal TP divided by TP plus Fn. So the perfect score is 1. F measure is a harmonic mean of precision and recall. So F measure equal to multiplied by precision multiplied by recall divided by precision plus recall. Any questions about all these metrics? So when we create our classifier, we have to evaluate this classifier, and all these metrics can be used to evaluate our classifier. So this is an example of a classifier of evaluation of a classifier. So precision, for example, in our example, the precision to calculate the precision of our classifier, we will divide 90 here divided by 230. This is the precision. And to calculate the recall will be 90, the same value, divided by 300. It is clear? Any questions about precision and recall? Hold-out method. So given data is randomly partitioned into two independent sets, training set, for example, 2 divided by 30 for model construction, and test set, for example, 1 divided by 30 for accuracy estimation. Random sampling, so it is a variation of hold-out, repeat hold-out k times accuracy is the average of all accuracies obtained. For cross-validation, key fold, there are key equal 10 is the most popular. So in the cross-validation, this is all the whole of the data, the whole of our data. We will divide this data into k or k subsets. Okay, in the iteration number 1, we will use all this data for training, and this data only the subset for test. And in the iteration number 2, we will use all this data for training and this one for the test. In the iteration number 3, we will use this data for training, this for test, and this for training, etc. So we will repeat how many iterations in here? How many iterations? K iterations. 3 here, 3. But if we have 1, 2, 3, 4, 5, and the first iteration, this is it will be the test, and the second iteration, this will be the test, and the third iteration, it will be the test, etc. So K iterations. K iterations. After that, we will make the average of accuracy of all these iterations. This is the cross-validation. So cross-validation randomly partition the data into k mutually exclusive subsets, and at each iteration you will use DI as test and others are training. Leave one out, k false, where k equal the number of tuples for small sized data. So the leave one out is an example of cross-validation, but the k in this case is the number of tuples. For example, if we have 200 tuples, we will make 200 iterations, and in each iteration we keep only one tuple for test and the rest of all the tuples for training. Stratified cross-validation faults are stratified so that class distribution in each fault is approximately the same as that in the initial data. Any questions about all these methods to evaluate the classifier accuracy? So keep in the mind that there are many metrics to evaluate a classifier: the recall, the precision, the accuracy, the F measure, and there are different manners to evaluate the classifier. We can make holdout method with random sampling, cross-validation, or in the cross-validation we can leave one out. We can make stratified cross-validation. Also, bootstrap is an example of evaluating classifier accuracy. Just a moment, please. This one. Okay. I represents the number of iteration. I will create a simple example. This is our data set. I will use k equal 3. So k equal 3, that means I will divide our data set in 3 subsets. This is the first one, this is the second, and this is the third. So for I equal 1, I will use training equal 1 plus 2, test equal 3. For I equal 2, the iteration number 2, the training will be 2 plus 3. The test will be 1. In I equal 3, the training will be 1 plus 3. The test will be 2. For each iteration, I will calculate the accuracy of our model. Here, accuracy number 1, accuracy number 2, accuracy number 3. After that, I will calculate the mean of all the accuracies. This is validation, cross-validation with k equal 3. It is clear, Ahmed? Okay. So what are the issues affecting model selection? The accuracy, classifier accuracy, the speed, time to construct the model, the time to use the model, the robustness, handling noise and missing values, the scalability, efficiency in disk resident databases, and interpretability, that means understanding the model. Other measures, for example, goodness of rules such as decision tree size or compactness of classification rules. All these are issues affecting model selection. There are many techniques also to improve classification accuracy, ensemble methods. So ensemble methods, that means we will use a combination of models to increase accuracy. We will combine a series of k-learned models with the aim of creating an improved model. There are many methods, ensemble methods like bugging, boosting, etc. So for bugging, averaging the prediction over a collection of classifiers. For boosting, weighted vote with a collection of classifiers. So we can you can see more details about all these techniques and here the summary of this chapter. Any questions about this chapter? You are welcome. See you next week inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.